We have Kahtaf with us today. He's the head of engineering and applications lead at Vana. And this is I think the first technical session from Vana, where he kind of give a deep dive of how Vana under the hood works and how Vana protocol architecture works actually, and how can you, and the next workshop on Friday, we'll actually discuss how to build your first data DAO. So yeah, over to you, Kahtaf.
Thanks, Muskin. How's it going, everyone? Thanks for joining us. I'm based in Toronto, so it's morning, but I know everyone is kind of around the world, so whatever time it is, thank you for joining. My name is Kahtaf. I am the head of applications at Open Data Labs, and as Muskin mentioned, we'll be talking today about the protocol architecture as a whole. So let's dive in. Feel free to interrupt me with any questions at any time. But yeah, so let's dive into an architecture overview. So Vana solves the fundamental problem of turning private data into a tradable asset while preserving privacy, right? And it does that by through 5 core components. So number one, wallet is your on-chain identity, DataDAOs, secure compute, L1, and the dual token system. So starting from the right side, your wallet is your on-chain identity, and data contributors exercise ownership over their data through their wallet, and all the data is tied to their wallet. Moving on to DataDAOs, these are decentralized data collectives that aggregate similar types of data, and then they do this by using our secure compute layer. And these are trusted execution environments that run proof of contribution, enforce on-chain permissions, and compute over private data while maintaining privacy. And then all of that is kind of recorded on-chain. So the Vana Layer 1 is an EVM-compatible blockchain that's specifically optimized for private data. So things like data ownership records, cryptographic verifications, permissions, economic flows, they all live on-chain. And we've got the dual token system that's powering all of this. So Vana is the native token of the network, and VRC20s are issued by DataDAOs that represent the underlying data set. So we'll dive into some of these components into deeper detail. So let's start with the L1 itself. So the Vana L1 is an EVM-compatible blockchain, which should enable familiar smart contract development. If you've worked with Solidity on Ethereum or other chains, you should be pretty familiar with how to build for Vana. It's powered by proof of stake consensus. And basically what that means is any kind of, all the validators that are powering the network, they have to throw up some stake to ensure that their incentives are aligned, and any kind of ill behavior towards the network results in slashing of that stake. So they're all incentivized to be truthful in how they operate on the network. As I mentioned earlier, Vana is the native currency of the network. It's used for staking, governance, paying transaction fees, as well as paying for data access fees. And DataDAOs issue their own tokens called VRC20s. And VRC20s are very similar to ERC20s, but for data. So VRC20s are the tokenized representation of the underlying data set. And you can think of it as, if Vana is the dollar, VRC20s are the company stock. So if we move up one more layer higher, let's talk about smart contracts. So the protocol is powered by several key smart contracts on the network. And as a DataDAO builder, you're going to be interacting with a couple of key smart contracts. So we've got the data registry, the DLP registry, the DLP contract, and the TE pool. If you're not familiar with smart contracts, they're basically like a server-side script that runs automatically when certain conditions are met. But instead of running on a centralized server, it runs on a decentralized network. And this allows us to build applications that are, in a trustless manner with transparency and reduced reliance on centralized authorities. So the Vana protocol operates through a couple of key smart contracts. So starting off with the data registry, this is the catalog of all the files added to the Vana network. So it merely stores pointers to where the encrypted data lives on-chain, off-chain. We don't actually store the data on-chain. And each data point is linked to cryptographic proofs that were generated by Vana's TEs and any permissions that the user granted to any third party, and pointers to the structured version of the data called refinements. So you can see that in the smart contract itself, it's just pointers that point to off-chain proofs, refinements, and the files itself. And the DLP registry is where DataDAOs or DLPs, they can permissionlessly register themselves and manage where their DLP contract lives. And the DLP contract keeps track of file submissions to the DLP, distributes rewards to users based on the results of the proof of contribution. And lastly, the TEE pool, which is the orchestrator of all of the secure compute that happens on the Vana network. So it kind of load balances proof of contribution jobs that DataDAO submit. And so, yeah, the L1 and smart contracts, they're permissionless infrastructure for building and maintaining DataDAOs. It provides the foundation, but the real magic happens in DataDAOs. So I won't go too deep into what DataDAOs are, but just as a brief intro, DataDAOs are collectively governed data sets. So decentralized data collectives, they aggregate specific types of data. And so you can think of it as like pools of fitness data or social media data, financial data, medical data. Yeah, Leslie, go ahead.
Yeah, just like one thing, Kahtaf, like a lot of like folks here, like they don't come from like Web3. So can we actually kind of like dumb down little things like what does a decentralized network means, like what does TE means, like that might do like new things for folks here. So yeah.
Oh, perfect. Yeah. No problem. I'll go into some of these more Web3 concepts in more detail then. Maybe I'll stop here for any kind of questions about some of the topics I've talked about already. To answer that question, what does a decentralized network actually mean in layman terms? So think of it as if you're talking about Bitcoin, Ethereum, there is no one central party that runs the Bitcoin network, the Ethereum network. If there's no central bank, it's actually run by thousands and thousands of machines and computers all over the world that collectively decide that this is the next state of the blockchain. So it's next to impossible to take control over, and there is no central governing body. So that's what a decentralized network actually means. And Vana operates in the same way. There is no one central node that runs the protocol. It's run by several what's called L1 validators all over the world. Could I talk more about tokens and how they actually work, like the Vana VRC token? Yeah, for sure. So a VRC token, a VRC20, similar to an ERC20, is basically a smart contract that operates on the Vana network. So where Vana is the base currency of the network, it's used to pay like transaction fees, data access fees and stuff. So, VRC20s live one layer up above that, and it's a smart contract that that basically has a set of rules built into it, and it's treated as a token that you can trade, you can perform any kind of financial transactions on, but it's specifically tied to the data that's represented by the DataDAO. So a VRC20 represents the value of the underlying data set. So if you've got a DataDAO that's, let's just say the Reddit DataDAO, when you contribute to the Reddit DataDAO, they will issue something called RDAT, which is their VRC20. And this is the token that the data contributor gets back, and it represents ownership in the Reddit DataDAO, and the data contributor can use it to vote on data access policies and vote on what happens in the Reddit DataDAO, and so on and so forth. So it represents collective ownership within the data pool. Yeah, just to summarize, VRC20s is the tokenization of the underlying data set, and the rewards, it's distributed to data contributors based on the data quality. So after running proof of contribution, the DataDAOs will know like, oh, this data point is really valuable, or this data point is not that valuable, and will reward the user accordingly. with the appropriate BRC20 token. So we've covered the L1, we've covered smart contracts and DataDAOs. So now let's move on to secure compute. So how do you actually run compute over your data without ever seeing it? And that is a problem that TEEs, or trusted execution environments, solve. And TEEs provide like a hardware level memory encryption and isolation guarantees to help ensure that no one can see the data that's being operated on, not even the TE operator themselves. So the code runs exactly as it's written, with cryptographic proof that the data hasn't been tampered with, and this is called attestations. So anyone can verify that this machine, this trusted execution environment, is running this specific code, and it hasn't been altered with, it hasn't been tampered with, and the memory space that it's running in is encrypted. So even if I have physical access to the machine itself, I can't plug something in to see the data that's being operated on. And we use a network of these machines in the Vana network. And TEs themselves, they have various architectures. They're built in different ways. Here at Vana, we specifically use the Intel TDX architecture. Let's move on to how data moves around the Vana networks, so the data lifecycle. And there's really 4 key stages: contribution, validation, refinement, and data access. Moving from left to right here, the data contributors will contribute their data to a DataDAO. The DataDAO will then validate that data point and write the cryptographic proof of that data point on chain. And they'll grant the appropriate permissions for that data. And then the DataDAO will refine it. And what refinement means is basically taking an unstructured data point and turning it into a structured one. And this allows us to query the data. So imagine, I'll talk briefly about refinements in a bit, but at a high level, imagine having a Amazon GDPR export. It's just a zip file of CSVs, JSONs. It's very hard to query. Once it's refined, you can issue SQL queries against it. So that's what refinements are. And then on the other side, once this data is refined and available, you have data buyers like AI builders, machine learning engineers, companies that want access to certain data. They will come and access that data. So contribution, validation, refinement, and access. So zooming in and focusing on the contribution stage. So your data source can come from anywhere, and we really specialize in private data. So your data source can be a GDPR export off of platforms like Reddit, Facebook, Instagram. They all offer a way to export data in bulk off of their platform. It can be an API request. So maybe you ask the user to sign into their Spotify account, and then once they've signed in, you can make API requests on their behalf to gather their Spotify information. It can be documents that they own. It can be various multimedia like pictures, images, videos, scraped content off of private websites. So by private, it means like beyond a login screen. So it can be scraped content once you've logged into your Facebook account, for example. So whatever your data source is, as a DataDAO, it's your responsibility to guide the user to get that data appropriately. And then once they have that data, it's encrypted with their wallet and then uploaded to an off-chain storage. And we recommend that this off-chain storage be user-owned. So what that means is it would be more preferential to upload to the user's own Google Drive account or the user's own Dropbox account, as opposed to a centrally managed, a DLP managed S3 bucket or a DLP managed storage. I mentioned encryption earlier, and I'll talk briefly about how encryption works in the Vana protocol. So starting off with, you've got some plain text data. We use something called the symmetric encryption, and what that is basically you have one random string that will both encrypt and decrypt the data, and this string is generated by signing a message. So for what that means is that as a Web3 user, if you've got your wallet a Web3 app can prompt you to sign a message. So, for example, in your MetaMask, you can get a request from a Web3 app to sign a message, and this message can be anything. So in this example, it just says signature request, please sign 1, 2, 3, 4. That string, it can be anything. And then once you've signed it with your wallet, you just click a button and it generates a signature. And this signature is unique to both that string as well as the wallet itself. So if everyone here were to sign the same message, it would output something different. But if I sign the same message over and over again, it would output the same thing. So the result of that is a signature, and that is the key that we use to sign the file. I've got a question here. Do you need to know Web3 protocols to create DataDAO? At a very basic level. So by Web3 protocol, like signatures are something that's pretty like a basic to any kind of Web3 Web3 application. And actually, if you've ever used any Web3 application, it'll ask you to sign in. And a lot of Web3 apps, they authenticate through signatures. That's how they know who you are. Because once you have the signature and the actual string that was used to generate the signature, you can determine the wallet address. And that's how many Web3 applications know who signed in just now, by asking you to sign a signature and getting the corresponding signature. Another question here is using private data fully legal? I won't go too deep into the legal aspects of it. I think we might have a session for that, separate session for that. I don't have a legal background, but we've designed the protocol to be to work with private data in a fully legal way. Next question: data anonymization, such as PII, PHI, relevant concept with this type of security. So I'll touch on data anonymization during the refinement step. I'll save that question for a little bit. Do you use TLS notary or hardware attestation on top of TLS, standard TLS? We don't use TLS notary on top of hardware attestation at the protocol level. So if you're speaking specifically about how RTEs attest, we've partnered with Vala. Vala is the provider of RTEs, and they've been in this game a long time. And they have something called Vala Cloud, where attestations are generated for us automatically. Clarify why it's better to have users keep their own data, like Google Drive. So yeah, that's a great question actually. So Vana is, if you've heard any pitch from anyone here at Vana, the words you'll probably hear are Vana is a network for user-owned data. And what it means for data to be user-owned is that the data is actually owned by the user. They should have control over it. We're not breaking down data barriers just to put that data in another barrier, right? So me personally, I would feel more comfortable knowing that I've uploaded my data to a DataDAO and the actual raw data is sitting in my Google Drive that I can, have control over it at any time. I can delete it if I wanted to, versus if I uploaded it to a DataDAO's S3 bucket that I have no control over, and I kind of have to rely on the DataDAO themselves to delete that data for me. So that's why it might be better to offer user-owned storage. So yeah, that's the encryption flow, basically using the signature as this encryption key, and this allows us to decrypt the file using that same signature. So when it comes time to decrypt, we can just prompt the user to sign the same message. They'll produce the same signature if they're signed in with the same wallet, and we can then symmetrically decrypt that file. And if we need to share the files with a trusted with a trusted party, what we can do is we can encrypt that symmetric encryption key with the trusted party's public key, and that way it's a secure way of sharing that super secret encryption key with trusted parties. So going down the data lifecycle, moving on to the validation stage, I want to talk a bit more about proof of contribution. So proof of contribution is the framework for data integrity in Vana. It has 4 key components: authenticity, ownership, uniqueness, and quality. And so basically the point of proof of contribution is, okay, so you've got this encrypted data that's sitting in storage. How do you know if it's actually valuable, right? So this is where proof of contribution comes in. So the 4 categories: authenticity, is the data real and unmodified? Did someone edit it? Did someone generate it through AI? Ownership, so does the contributor actually own this data? Uniqueness, has this DataDAO seen this data before? Like, is the same user uploading the same data point 10 times to just get more and more tokens? And quality, like how valuable is this data for the DataDAO's purpose? If the DataDAO's collecting data for training an AI model, does that next data point really have a significant impact on how that model is trained? So to give you some real life examples, I'll talk about the ChatGPT DataDAO. So how they might prove the authenticity and ownership of a file is, if the contributor exports a zip file and that has all of their chats in it from ChatGPT, they can submit this file, but also the link from the email that you get from OpenAI when your export is ready. And then during the proof of contribution step, we can compare the checksums. We can download the file from the link that was shared, and we can compare it to the checksum of the file that was uploaded by the user themselves. And how they might solve for uniqueness is using something called fingerprinting. So we can generate something called feature vectors, which is basically a way to represent files as a string. And if a small data point in that file changed, let's just say you changed your name, for example, in a 1 megabyte text file, the files are more or less similar, but the fingerprint itself will change slightly. It's different than a hash. When even 1 byte changes in the file, the hash changes completely. So a fingerprint is a way to represent, like, capture changes within files. And we can load this up in a vector store and see how similar each file is. So that way, if people are tweaking just small bits of it, we have some guarantees that, maybe we've seen this file before. And quality. So the ChatGPT DLP might assess quality by taking sample conversations from their chat and evaluating it with another LLM. So for the purposes of training an LLM, how valuable is this chat? Maybe it returns a score from 0 to 10 in terms of quality. And those are some real life examples of how proof of contribution might work. And of course, it's very different based on the kind of data that you're trying to validate. So there is no one general proof of contribution that'll fit all types of data. So next I'll talk about the refinement step. And as I was mentioning earlier, this is how we take unstructured data and turn it into structured and queryable data. So with the Amazon example I was giving earlier, if you export all of your data off of Amazon right now, you'll end up with a zip file that is hundreds and hundreds of files long, containing like images, CSV files, JSON files, TXT files, and so on and so forth. That data itself is useful, but kind of hard to work with. So as a DataDAO, it's your responsibility to refine it into something more useful and queryable. So the standard we've chosen for this is libSQL. libSQL is a modern fork of SQLite, and we're basically going to be transforming all of that raw data into an SQLite data point so that we can issue queries against it. So imagine being able to issue a SQL query like select star from orders where price is greater than 10 to get back some of the more expensive orders. That would be really difficult to do if your data is kind of in this unstructured format. There was a question earlier about PII, and during the refinement step, you as a DataDAO can decide, is there any PII in here that's really that's really sensitive that you might not want to include in your final refined form. So let's just say you've got a zip file of social security numbers. Maybe you don't want to. Maybe you want to just include the last 3 digits or the first 3 digits of the social security number. You can do that during the refinement step and basically mask out any kind of PII that your DataDAO will never reveal. Maybe it's some guarantees that you make to your user, and this is your opportunity to do that. So let's talk about the refinement in a bit more detail. So DLPs are responsible for building a Docker image that gives us instructions on how to transform this this raw data into structured data. Similar to proof of contribution, it's basically instructions for how to validate your data. Refinements is instructions on how to structure your data. And the way this works in Vana is for both proof of contribution and refinement, we ask that DataDAOs build a Dockerized image that'll run on our secure compute environment. So we've got templates for both the proof of contribution as well as refinement, where you can basically get started using Python to give us instructions on how to transform your data and work with your data. We've got services called the refinement service. You can self-host this, or you can use our hosted version that will take this Docker image and it will take the encrypted data, decrypt it, and run it through your Docker image and output a refined data set. And as a precursor to running the actual refinement, you have to register your schema on chain. So what this means is that you as a DataDAO, maybe you are building the Reddit DataDAO, you've got a schema that defines all of the tables in your DataDAO. So maybe specifically for Reddit, you've got tables for posts, you've got tables for users, for comments, things like that. We ask that you publish the schema on chain so any kind of data buyers can trustlessly see that this is what your DataDAO collects, and this is the format that it's in. And then once you've got the refiners set up, a new data point comes in. We run your refinement Docker image. We generate the refined SQL data point, encrypt it, and then it's added to the data registry as a refinement. And then I'll talk a bit more about data access, which is the last part of the data lifecycle in the data access workshop that's happening in a few weeks, where we'll talk about how this data is aggregated. We'll talk about how to run a compute against this aggregated data, how to price your data sets, so on and so forth. So I've got a question here. Can there be hierarchies within DataDAO, like polymorphic root with more specific leaves? I don't quite understand that question, Gauri. Would you mind explaining that a bit further?
Yeah, hi. So basically what I'm going to find out is, like, you have these classes, right? Data classes where you say, like, preferences, right? There might be a DataDAO for my preferences, but then I have specific preferences for travel, and maybe specific preference for foods. And so would there be, like, do you envision different DAOs for travel and food, or is it just my preference? Because eventually I might be interested in looking holistically as a human being's preference rather than, and there may be some correlation. So do you have that in mind?
Oh, that's a great question. So the way I understand your question is, should we have different DataDAOs for different kinds of data? And my rule of thumb for that is, can the underlying VRC20 token accurately represent the data that is being collected by this DataDAO? So if you've got a DataDAO that collects data from 5 different sources, let's just say Netflix, GitHub, Reddit, so on and so forth, in the category of social media. Sorry, not Netflix, but like Instagram, Snapchat, so on and so forth, in the category of social media. It's the social media DataDAO. But however, Reddit, Snapchat, Facebook, these are all very different data sets, and it might not be accurately represented by a single VRC20 token. In that case, it would be better to split those up into 5 different DataDAOs, the Snapchat DataDAO, the Reddit DataDAO.
I have a follow-up question then.
Yeah.
And that is, so if let's say that there are all of these different DataDAOs, is there a concept of creating a collection of data from those DataDAOs for some higher order wisdom?
Yeah. So I think what you're asking is, will you have the opportunity or the ability to kind of query all of this data that all the DataDAOs are collecting in a way that you can draw insights from other DataDAOs as well?
Yeah.
And then that is, yeah, definitely. So the reason that we refine this data and put it all in a common format is so that not only that we can issue SQL statements to a single DataDAO, but across DataDAOs as well. In the future, in the very near future, we're going to enable the ability to run queries across various DataDAOs. And you can imagine being able to run a query like, give me all of the sleep patterns for everyone that listens to punk rock music. Because maybe you're trying to do some analysis on your music preferences, on how it affects your sleeping habits. And that's definitely possible, going to be possible.
And that would be on the consumer side, the AI side of things.
Exactly. Yeah, exactly.
Thank you.
Perfect. I've got another question here. Will Vana help us learn this proof of contribution, or is it something that as a future DataDAO creator, we'll have to learn to do? And the second question, refinements is a service we can work with on Vana, if understood correctly. So that first question, will Vana help us learn proof of contribution? Definitely. We've got a lot of channels for you as builders to reach out to us on. So our primary channel is the Vana Builder Discord, where you can drop any questions. I'm also happy to take any questions right now about proof of contribution specifically. If there's anything that was unclear about what proof of contribution is or how it might work for your specific data set, do let me know. You can always reach out in the Builder Discord to learn more. And refinement is a service we can work with on Vana. So the refinement service is something that we've open sourced. You as a DataDAO builder can choose to host it yourself, but you can also use our Vana's hosted version as well. And basically what the refinement service does is takes your refinement Docker image and runs it against every single data point that your DataDAO ingests. So putting it all together, so we've talked a lot about secure compute, smart contracts, a proof of contribution, refinements. Now, if we were to sum it up into one large diagram on summarizing how data is ingressed into our network, this would be it. So basically, we've got on the left here the DataDAO UI. So the parts in green are the parts that DataDAOs are responsible for building. So that in this case, it's their contribution UI, the contract, the DLP contract itself, and the two Docker images that represent the proof of contribution, as well as refinement instructions. What's not shown here is the corresponding VRC20 token. So that's also the DataDAOs are responsible for. So putting the flow together, we've got your data contributor that lands on your DataDAO UI. Let's just say they've got their Reddit data ready to go. They will encrypt it and they'll add it to the data registry, which is a smart contract inside the Vana L1. Once they've added that file, anyone can add a file to the network, but now it's your responsibility to validate if this file is useful or not. So what we're going to do is you as the DataDAO, you're going to request verification from the TEE pool, which is going to assign a TEE or a secure compute to your job, your proof of contribution job. Once a TEE is assigned, we'll send the encryption key and the proof of contribution Docker image right to the TEE itself. No middleman, just the DataDAO and the TEE. And it will run that secure compute. It will decrypt the data point. It will run through your set of instructions that validate if this data is useful or not. And then it will generate something called a proof. And this proof has some metadata about, it contains assertions about the data. So the data itself is encrypted on-chain. How can anyone come in and look at the public blockchain and see that, hey, this encrypted data is actually valuable or not? So if we're talking about the Reddit data point, for example, maybe you measure value by how many DMs a data point has. Maybe you measure value by how long the user has been active for on Reddit. Maybe it's 10 years, maybe it's 3 days, right? One is more valuable than the other. So these kind of metadata you can publish in the proof itself. And these proofs are public, so obviously we don't want to reveal any private information, but just some sort of public metadata that has some assertions about what this encrypted data point has. We generate the proof, and then we write it to the data registry. So along with this encrypted data point, we have some proof that that makes some certain assertions about the data. And then going on to the refinement stage, in a similar way, we send the encryption key and the refinement Docker image to the TE, and it basically transforms that raw data into a SQLite format and encrypts it, and then also adds that on chain, adds a pointer to that on chain. So now the data registry contains the pointers to the encrypted file, the proof, and the refined data point. And then once we have all that, the DataDAO will reward the user with the appropriate ERC20 token for their contribution, and that's the reward flow here. So that's all I have for today's session. I want to thank you for taking the time out of your day to attend, and yeah, I'm happy to take any questions that you might have.
Thanks, Kahtaf. Any questions, guys? I know this is a lot. It's not that simple to explain, like Vana's architecture. It's like they're kind of an intersection at both crypto and AI, and that's a lot going on. So yeah, just like I think ask all the questions you have about proof of contribution, TEs, how data storage works, like whatever questions you have, like we're here to answer. If not here, like just like bring your questions on Discord as well. Like Kahtaf and team will be there to actually like help you out there. So yeah, but yeah, we still have 20 minutes if you have any questions.
Muskan, there is a question in the chat.
Yes, Kahtaf, you want to take it? You're on mute.
Oh, sorry. A quick run through of data validation considerations for the ChatGPT DataDAO. Can you give an example of data validation query attestation, quality attestation in the context of another existing DataDAO like Reddit? Yeah, for sure. Great question. So I'll go back to contribution. The four metrics being authenticity, ownership, uniqueness, and quality. And I'll talk about how the Reddit DataDAO might do it. So authenticity and ownership, the way I recall the Reddit DataDAO doing it is we asked them to, like the data contributor, we asked them to make an edit to their profile. We generated a 6-digit PIN, and we said, hey, go put this on your profile. And then once they're done that, we would look at their profile and see if they have that PIN on their profile. So this allowed us to verify that, yes, they actually have ownership over the account that they say they do. In terms of uniqueness, I believe what was done there was the fingerprinting technique that I mentioned, which was to take some of the meatier parts of the export and generate a fingerprint from it and keep it in a vector store where we can see that that fingerprint is generated through their posts, through their comments, and things like that. We would be able to see that if this person duplicated the file and changed the username, for example, that fingerprint would remain more or less the same, and we would know that this is a duplicate file. And in terms of quality, I don't remember the exact metrics, but one of them was age. And you can actually, it was age, and I think it was like the number of posts and comments that they made. So we saw that some people were just creating an account and then without having any data in it, they would just export their zip file and submit it to the Reddit DataDAO. And the quality score would be 0 because you have really no content. There's no meat in that export. So that's how that was addressed. How does the network scale with the addition of storage? Have you tried integrations with IPFS, Filecoin, ARweave for decentralized storage? Yeah, that's a great question. So I didn't talk too deeply about storage and how it works on the Vana network, but the protocol itself is agnostic to the storage protocol that's used. So we use IPFS primarily to store the cryptographic proofs and the refinements, but the raw data, the data that the DLPs are, the DataDAOs are collecting, we don't make any kind of assertions or any kind of recommendations about where that data lives, other than we recommend that it be user owned. But as a DataDAO, you can choose where that data lives. All we really need is a URL to the publicly available but encrypted data point. So if that's on IPFS, if that's on Filecoin, if that's on an S3 bucket, that's the DataDAO's prerogative. Yeah. Can you explain the whole topic in brief? Omer, can you explain? Can you clarify the topic that you're speaking about here? I'll wait for a follow-up from you, Omer, before I dive into that one. I'll move on to the next question. Do we learn how to create a fingerprint, learn how to look for discrepancies? Yeah, I can point you to a repository that we have for generating such fingerprints. Yeah, I don't have the link off the top of my head, but I'm happy to share that with you after this call. And that's just one way to look for uniqueness. There could be other ways as well. You as a DataDAO, maybe you take a hash of certain properties within the file, maybe the username, that if we're talking about Reddit, for example, it doesn't necessarily have to be a fingerprint. Maybe it could be a combination of the username, the checksum of the file when the user joined, a combination of a couple of key properties, and then maybe you take a hash of that, and that can serve as the fingerprint. Non-techies hoping we can understand. Yeah, definitely. So I think we have a lot of non-techies in our builder community. So we're definitely working to make sure that we have the appropriate templates and examples ready, so that you don't really need to know some of these deeply technical concepts in great detail before you can start contributing. Next question here. So what are the key considerations for designing proof of contribution function for DLPs to balance data quality and contributor incentives? Are there any are there any templates and tools provided by Vana to simplify this? Yeah, great question. So key considerations for proof of contribution. So you as a DLP, it's your responsibility to make sure the highest quality data points get through, and we're not incentivizing like low quality data points. So I think if you do that, you're kind of setting yourself up for botting and just spam in general. So you as a DLP, it's your responsibility just to set up a really high quality proof of contribution, even if that means some data contributors will be rewarded less just because their data maybe is not that inherently valuable. So do we offer any default templates? We have templates for everything that I've talked about here today, including the DataDAO UI, the DLP smart contract, the proof of contribution, the refinements. We have templates for all of that. And I believe there's a session, I think it's the next session, how to create a DataDAO. One of our team members will walk you guys through exactly all the steps needed to create a DataDAO. And we've built this tool very recently, which kind of abstracts away a lot of these complexities. It's just issuing a few command line commands, and you will have all of these set up. I see Nissan's hand raised. Nissan, go ahead.
Hi, I just want to bring back something Art said yesterday about talking to AI builders, and I'm part of Build Club as well, one of the representatives in Brisbane. A lot of the questions people are asking is like, how do you get this data, and how do you think about manipulating it? There's this concept in data science called data wrangling. You do not have to be technical to understand how to take some data and manipulate it to what you want, but you probably need to talk to the more technical folks about what you're getting from these data exports, because this is private data, and how to transform it into what you want. So one step I would say is like, if you're a little confused about the private data that you're trying to consume and how to get it to the state you need it to be, maybe talk to one of these AI builders in that club about what's a way to like change that up, and maybe partner with them if they're not here in the academy to ask them to join you in the academy.
Yeah, definitely. Thanks, Nissan. I'll move on to the next question here. How does the file URL management work as the data on the user side if it gets updated continuously? So yeah, that's a fantastic question. So every contribution is a new file in the network, and you as a DataDAO can decide how you want to treat updates to the same file or contributions from the same user to your DataDAO. So you might be building a DataDAO for streaming IoT data. And these kind of DataDAOs, they will submit data from the same user multiple times, maybe even multiple times a day. you as a DataDAO should be responsible for figuring out if you want to just capture the delta between every submission, or if you want to write the entire file on chain. It's just whatever is most valuable to your DataDAO. If you're talking about the Instagram DataDAO, where you just collect like GDPR exports from Instagram, maybe like 90% of the data won't change between submissions, but maybe 10% of the data will, just because the user has had more comments, they've posted more to Instagram. But that GDPR export still has all of the data from day one. So maybe in subsequent submissions, you don't include the old data that you've already seen before. And that's really up to you on how you want to handle updates between, updates of the data. Next question, say the data contributor has their data on Google Drive. Is that copy of the data kept within a DataDAO, maybe kept within on AWS? So we recommend that no, DLPs and DataDAOs should not make a copy of the data. And this is primarily due to, of course, privacy concerns, but also that makes DataDAOs a data processor under GDPR laws. So we're trying to do everything we can to make sure that data is being handled in a way that's decentralized and secure. And we offer all of that infrastructure so that DataDAOs don't need to worry about it. And we recommend that, it's highly recommended actually that you shouldn't make a copy of the data, and that if you need access to the data itself, you go through the data access channels, which we'll talk about in a subsequent workshop. I think we've got a few minutes left still. If there's any more questions, I'm happy to take them. Just got another one. Key considerations for proof of contribution function. Can you revisit this? Sam, was there a particular topic or idea that you'd like me to revisit about proof of contributions? Dynamic pricing. Sure. So I think what you're referring to there is, how do we figure out if two users submit different data points, how do we figure out what to incentivize them with? Like, how do we reward them appropriately? So in the proof of contribution function, everything, it boils down to the 4 scores of authenticity, ownership, uniqueness, and quality. Each score ranges from 0 to 1. And then we've got a final overall score of 0 to 1 that represent that data point, that file. And in your DLP contract, we take that score and we multiply it by some multiplier that you pick. And that is how many tokens to reward the user. So to give an example of that, if in the Reddit DataDAO, you've got a brand new user that submits low quality data, maybe their score in the 4 categories is like very low, 0.1, 0.2, and then their final score, which is again a formula that you as a DataDAO builder decide, is very low, like 0.1. You take that score and then you take that multiplier that you decide as well to turn that into number of tokens. So maybe 0.1 times the multiplier results in like 1 RDAO token. Whereas if you take a high quality file that received a score of 1, you multiply by that same multiplier, and that results in 10 RDAO tokens. So that's the template that we have for dynamic pricing. But of course, if your use case is way more custom, you're free to modify that yourself. Do DataDAOs get incentives from Vana for data collection, like double XP? I think what you're asking is the DataDAO reward system. So we reward DataDAOs with liquidity of their VRC20 token. So we'll talk more about that in the VRC20 session. But basically, liquidity is really important when you're launching a new token and launching a new VRC20 token. So for DataDAOs that are very active, that have a lot of users contributing to their DataDAO, that have users accessing that data, we reward them appropriately with liquidity to their VRC20 token pool. Is there a roadmap of how we build, as you mentioned? So we'll talk a bit more about that in the create a DataDAO session. I think that's the next one that's happening on basically the key ideas that you need to understand when we're building a DataDAO. The proof of contribution is public, correct? Have you seen real-world instances where data buyers are skeptical of the attestation provided by proof of contribution functions? Yes, so the proof of contribution function is public, and we, similar to, for both the proof of contribution function and the refinement function, we require that these are publicly available GitHub repositories. The reason for that is, if me as a data contributor, if I want to see what's happening with my data, regardless of if it's on a secure server, if the code that's being executed, I need to be able to trust it if I care to look. And I want to be able to go to a DataDAO and see, oh, hey, this is how they're evaluating my data point. Oh, this is how they're structuring my data point. If they slide in some code in there to copy my data point to an S3 bucket, I'll likely not, contribute to that data point to that DataDAO. So, have you seen real-world instances where data buyers are skeptical? If they are, they can basically go to the public proof of contribution, the public refinement images, and see how their data is being handled. So the protocol itself doesn't make any assertions about what the proof of contribution should do. We just assert that it should be public and attestable and verifiable, so that if any of your data contributors question you, or if any data accessors question you, you can point them to the repository. This is how we handle your data. No worries, no worries. VRC 2015. Oh, go ahead.
I have a quick question on the Vala. You had mentioned something about Vala.
Vala, yeah, the Vala network. Go ahead.
Is that something I can Google or?
Yeah, I'll drop their website in the chat here.
Great, thank you.
Vala.network. And basically, these guys have been in the game for quite some time, and they're one of the leading vendors of TEs in the Web3 space. And they recently rolled out something called the Vala dashboard, where you can deploy a TE within minutes and be able to deploy some code against it and have a full attestation report of what this code is doing that you can share with anyone. Perfect. Any other questions before we end the session here?
I think that's it, Kahtaf. Yeah.
Perfect. Well, I want to thank everyone for attending their session, taking some time out of your day to learn a bit more about the protocol and the architecture. As always, I'm available in the Builder Discord. Feel free to reach out to me there.
Cool. Thank you so much, Kahtaf. Thanks, everybody. Thanks for joining. All right, bye.
Thank you.